Okay, let's start with a little puzzle for your brain. How does it instantly know what the word it means in a sentence?
Okay, so look at this sentence. Your brain, right away, knows it is the cat. The cat was full, not the food. You don't even have to think about it, you just get it. Well, it turns out that that simple little trick, that thing your brain does without breaking a sweat, that's the core idea behind an AI that has, and I mean this literally, changed everything. And that technology is called a transformer. So in this explainer, we're going to peel back the layers and see exactly how these things work. We'll start with the very first step, how they even begin to understand what words in a sentence actually mean.
So at its heart, what even is a transformer? If you remember one thing, make it this. It's an AI model that gets the full picture by looking at everything all at once, and then it decides what's most important. It's all about context.
All right, so before a transformer can figure out what matters most, it's got to learn to read, right? But here's the catch. Computers don't see cat or dog. They see numbers. So the very first hurdle is, how do you teach a machine to think about language in a way it understands? Numerically. And here's the game plan for how it does it. It's basically a 5-step process. We start with numbers, add some context, find the important connections, think about them for a bit, and then, you guessed it, repeat the whole thing over and over to get smarter. Okay, step 1. We're turning words into numbers. Every single word, and I mean every word, gets translated into this long list of numbers called a vector. Now here's the really cool part. Words that mean similar things get similar numbers. So the numbers for king are going to be way closer to the numbers for queen than they are to, say, banana. It's like a mathematical map of meaning. All right, but what about word order? This is a big one. Since a transformer is looking at all the words at the same time, it could get confused. We have to give it a little cheat sheet about where each word is. This is called positional encoding, and it is absolutely crucial. Without it, think about this. Dog bites man and man bites dog would look identical to the computer. And we all know those are two very, very different situations.
Okay, so we've got words as numbers, and we know their order. Now we get to the real magic. I'm serious. This next part is the absolute heart of how transformers work. It's all about a mechanism called attention. So let's try another one of these puzzles. Just like with the cat at the beginning. Check out this sentence. What does the word it mean here?
Is it the water or is it the glass? Now, you've already figured this out, no problem. But how does a machine do it? It has to learn which other word in that sentence it should be paying the most attention to. That's the key.
And what do you know? The model does the exact same thing our brains do. It figures out that it is all about the glass. It gives a really high attention score to the word glass and a super low one to water. Boom! It gets it right. The glass was empty. So here's how this self-attention thing works, and this is the really wild part. Every single word looks at every other word in the sentence, all at the same time. It's like a big conversation. It crunches the numbers, figures out which connections matter most for context, and builds meaning from there. And the killer feature? Because it's all happening at once, in parallel. It is lightning fast. So after the model figures out what to pay attention to, all that information gets sent to a little processing station. You can kind of think of it like the model just taking a second to think deeper about the connections it just made. It's like letting the new information sink in and refining its first guess. And here's the thing. It doesn't just do all this once. This whole process, attention, thinking, it's stacked. It's like building with Legos. One layer might only get the most basic connections. But when you stack dozens of these layers on top of each other, well, that's when the model starts to build a really deep, almost intuitive understanding of grammar, context, and even what you're trying to say.
Okay, so now that we've got all the building blocks, let's zoom out and see how they fit into the bigger machine. Most of the transformers you'll see out there have two main parts. There's one part for understanding stuff and another part for creating stuff.
These two parts are called the encoder and the decoder. And honestly, the best way to think about them is just reading and writing. The encoder's whole job is to read the input and really truly understand it, say reading a sentence in English. Then the decoder takes that deep understanding and its job is to write the output, like translating that sentence perfectly into Hindi.
And when you put all of this together, well, that's what sparked the transformer revolution. Seriously, these unique mechanics gave this AI a set of superpowers that older models just couldn't compete with. It wasn't just an improvement, it completely changed the game in AI.
So what are these superpowers exactly? First, they see the whole picture at once. Second, they can connect the dots between words, even if they're really far apart in a long paragraph. Third, they learn super fast because of that parallel processing we talked about. And finally, and this is a big one, they scale like crazy. The bigger you make them, the smarter they get. It's a game changer.
And the results? Well, these superpowers are behind so much of the tech you probably use every single day. We're talking about the smartest chatbots, instant translation, the search engines that just get what you're asking for, tools that summarize long articles, even tools that write computer code for you. Yep, all of that is powered by the transformer architecture we just broke down.
So if you walk away with just one thing from all this, let it be this simple but powerful idea. Transformers understand language because they let every word look at every other word and figure out for itself what's important. That's it. It's that simple in concept and that revolutionary in practice.
And that brings us to a final big question. We started this whole thing with a simple puzzle that humans are great at, understanding context. Now that machines can do it too, what do you think is the next big human puzzle they're going to help us solve?